I change when I use double stroking. I change this one. This is south. So how am I going to stroke? I will be stroking from the middle sideways. Like this. Like that. Like that. Like that. Several times. You will see the reason as to why I did this. Now, okay? All materials have got what? Molecules. But a material that has not been made a magnet has molecules facing the molecules are disorganized. That's why it is not able to become a magnet.
Plastic.
No, we are talking about those magnetic materials, okay? Magnetic materials have only disorganized molecules, but they are able to become. So because the molecules are disorganized, it can't attract other things. But if we organize these molecules to face one direction, like this, then a material becomes a magnet. If we organize these molecules like this, they all arrange themselves like that. Are we there? Then all of them will become, this material will become a magnet. So when you look at these magnets, all these magnets, their molecules are now like this. That's why they are able to attract. They have a north pole. These molecules have the positive side and the negative side. Or the north pole and the south pole. So this side will be the south, that side will be the north. Now, when you are stroking this material, do you know the reason as why I'm lifting it up?
No.
When I stroke like this, I must lift higher, because if I did this and this, what am I trying to do? I'm trying to organize, disorganize. Organize, disorganize. So you will not make a magnet. That's why I am lifting it higher, so that those ones that accept to sleep there should remain sleeping, not again disorganized. Are you getting the point?
Yes.
That's why we lift it higher, to avoid disorganizing the molecules. That's why if you're stroking, you do this higher, 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 so that you are only sweeping them to sleep on one direction, to face one direction. That's the reason that's why we are lifting. That is under stroking method. Then in my we have finished induction. You just attach a magnetic material on a magnet for so long, it will become a magnet. 2, stroking method. We have single stroking method. When you're doing single stroking, you use any pole. You can use north pole or south pole. But when you're stroking with the 2 magnets, you make sure one pole is north, the other pole is south. Maybe another thing is, how do I determine the north pole of the material I have magnetized? How do I know the north pole of the material I've magnetized? Yes?
The side you have been stroking.
Now, which side is this one? I told you? North pole, isn't it? We are going to color this magnet so that we know properly. This is north pole. So when I use the north pole and stroke like this, where I end every stroke, is going to be the opposite pole. Which pole have I used?
No.
They can trick you. They will ask you, now how do I know the north pole of the magnet I've made through stroking? Tell them, if I've used the north pole, the end where I end the stroke is going to gain the opposite pole of the magnet I'm using. Are you getting the point? Are we together?
So that means if I use the south, you find the other side
is
is
the
north.
north, this side is the south.
And it's not permanent that you have to use the
North pole, you can choose. I can choose
you can
south.
choose any.
So when I use the south, when I end the stroke, it's going to get the opposite of the pole I've used. If I've used the south, this side is going to be the north. If I've used the north, this side is going to be the
South.
So this is what I've told you. Why I lift it up? To avoid disorganizing the molecules that make up the material. We are saying a material becomes a magnet once the molecules accept to face one direction. Then it will become a
one is the North Pole, which one is the South Pole. That's when you're carrying out to
Stroking method.
But now what if you're using the other solenoid?
Aha.
How do you determine
Now,
North Pole and the South Pole?
Very good. And those questions, the parents can trick you. Induction method, isn't it? That is what? Induction method. Induction what? Method.
Another one still.
Induction what?
Method.
I don't know whether this one will be strong enough. It
The
is not
magnet is not
weak.
strong.
It is
It's
weaker.
weak. You can use that
It's
bigger.
that big one.
Now, when I use, we're struggling again. Now, when do we use this bigger magnet? Realize if we leave these nails hanging here for so long, they will become. If this side of this magnet is the north, are you getting that? What is going to be the north of the first nail? How do you determine the poles of the nails? Now, if this is the north, this side of the bigger magnet is the north, which side can accept to stay on the north? Principles of magnets state that north poles, like poles repel, unlike poles attract. So if this is the north, this one is only able to stay here because this side is becoming the south. Are you getting that? This is the south, that's why it is able to remain on the north pole. If this is the south and the north pole, then this side is going to be the south. Are we together? If this is the south pole, the first side of the magnet is going to be the north pole. How? Like this. If I've used a magnet with a known pole, if this is the north and these are my nails, are you getting the point? So that means this side, because this is the north, the side that is attracted to the north is always a south. Then the end point